So hopefully you're back for the second part of the notes. So it says we want to write the following statement using symbolic language. It says, when a fraction of 57 is taken away from 57, what remains exceeds 2/3 of 57 by 4. So it looks like they give me information for everything. The only thing that seems like they don't give to me, it says when a fraction of 57. So we may need to investigate what does this mean a little bit. So a fraction of 57 means that it's some part of 57. It's not the whole thing, so it's not actually the number 57, but it's some part of it. So it's some number between 1 and 57, but I don't know what number it is. And since I don't know what number it is, that makes it our unknown, and our unknown should be our variable. So unknown means we need to define it as our variable. So I can say let x be the fraction of 57. And when I say that, I can replace this with x. So I'm just going to write a big O X on there. So when I read this, it says, when x is taken away from 57, what remains? Okay, so what remains is kind of like telling us, like, okay, what it's going to equal after we do that. And then we have a funny word here. It says exceeds. Okay, think about what exceeds means to you. Okay, exceeds means goes over, right? It can also just mean more than. So this is telling me that what we end up with, it's going to be more than 2/3 of 57. And they actually tell us how much more it's going to be. They tell us by 4 that it's going to be. So this is telling us that our answer is going to be 4 more than 2/3 of 57. More than 2/3 of 57. Sometimes when I'm going through expressions, sometimes I'll rewrite them like this so that my brain doesn't have to decode this again. I can just go back to my notes and see, oh, that's what I was talking about. So I'm going to read this one more time. When x is taken away from 57, it equals 4 more than 2/3 of 57. So let's talk about 4 more than 2/3 of 57. So this right here, this language right here, 4 more of 2/3 of 57, that's a part of a whole language, which means I'm taking this part of this whole language. So we should know that that's actually multiplication. So I'm saying 2/3 times 57, and if I have 4 more, then I'm saying, okay, add 4 onto that, 4 more than, usually addition, depending on where it comes in the statement, okay? Luckily for us, this is all numbers, so I should be able to solve all of this, okay? So one thing I'm noticing here is 3 can actually go into 57. 3 goes into 5 one time. We're left with 2. That leaves us 27. So this actually gives us 2 times 19 plus 4, which is equal to 38 plus 4, which is equal to 42. So now we know that this statement right here is actually saying just the number 42. So I'm going to circle that. And I'm going to read this statement again. X taken away from 57 equals 42. Now this looks like something I can start writing. X take away from 57. So we have 57. We're taking away whatever X is, and it equals 42. We're done. That's our answer. Okay. Let's take a look at our last two expressions. These are actually really cool expressions. When I first learned how to do this with numbers, I thought it was just the most amazing thing ever. And I hope that you kind of feel the same way too. So looking at this first one, it says the sum of 3 consecutive integers is 372. So to first understand this number, let's talk about integers a little bit. So integers are whole numbers that are either positive or negative. So when they're talking about the sum of 3 consecutive integers, consecutive is the key word here. Consecutive means they come one right after the other. So 3 consecutive integers could be like 1, 2, 3, but they could also be like negative 15, negative 14, and negative 13. Those would also be consecutive integers. Or we can have really big numbers like negative 1,021, negative 1,020, negative 1,019. Okay, so these are just some examples of consecutive integers, 3 of them specifically. But there's actually infinite combinations we can make of consecutive integers, which is what makes these problems so interesting, because we can actually create an equation that will solve it for us without us having to go through all of these combinations. But what's most important here is the pattern that I want you to see happening between these integers. So what I'm noticing here is that from 1 to 2, it's like I added 1, but from 1 to 3, it's like I added 2, right? The same thing from negative 15. If I add 1 to negative 15, I get negative 14. But to get from negative 15 to negative 13, I'd actually have to add 2. Okay, let's look one more time. So to go from 1021 to 1020, I'd have to add 1 because these are negative numbers. That's what's happening. But to go from 1021 to 1019, I'd have to add 2. So we see when we're talking about integers, the space as I go further away increases from the original number. So when you're dealing with consecutive integers, you generally want to let x be the first integer. So let x be the first integer. And I'm going to make kind of a little table here so we can see. First, second, third, because we're adding 3 of them, and I know it has to equal 372. I also know that I'm adding these together, okay, because they tell me sum. So if I let x be the first integer, then how could I represent the second integer if I know it's exactly 1 more than the first one? Well, that's like saying it's 1 more than x. If I wanted to write 1 more than x, I could write x plus 1. Okay. If I'm looking at the third integer, I know it's 2 more than the original integer. I know it's 2 more because it's 2 numbers away. Okay, if it's 2 more, then I can write x plus 2. So here I have my first integer, my second integer, my third integer. I'm adding them all together and it equals 372. That would be my final answer. Okay, so for our last problem here, we actually have 3 consecutive odd integers, and their sum is 93. So it says off here. It should say odd. Sorry. Okay, odd integers are different than regular integers because they're not just 1 away and then 2 away and then 3 away. Odd integers are different. So for example, I can have 3, 5, 7. These are consecutive odd integers. One comes right after the other in the sequence of numbers. But we'll see here, to go from 3 to 5, I have to add 2, not 1 this time. And to go from 3 to 7, what do I have to add? I actually have to add 4, not 2 as I was doing the first time. So if I wanted to write this, again, I want to start with x being the first one. So let's write down, let x be the first, and let's be specific, odd integer. And I'm going to make my little chart again. First, second, third equals 93. So x is the first. I need to figure out how do I describe the second and the third. So if you feel like you know how to do this, go ahead and write it on your paper. If you don't, then follow along. Okay, so again, I notice the difference between 3 and 5 is that 5 is 2 more than 3. So that means I want this number to be 2 more than x. Well, 2 more than x is x plus 2. And I want this number to be 2 more than this number, right? But this number is 2 more than this number. So 2 more and 2 more is how many more total? It's 4 more. So this means this is x plus 4. Okay? At that point, we would have our complete answer here. X plus 2 plus x plus 4 is 93. Okay, for the group work, I suggest you do the 2 problems for number 1, check in, 2 problems for number 2, check in, do the last problem, and then check in again.